Testing. There we go. Got it. Okay. That was 1 minute and 45 seconds wasted. Now, I can remember what I'm doing here. Yeah. So what I'm trying to do, did I flip myself? Left, right. Okay. What I'm trying to do, this is the advanced algebra and functions, which accuplacer, which I don't expect to do well on. But I did see a video that showed just using substitution for everything. And it should work. And I thought, I can do that. You just put 1 for x, 1 for, just replace 2 for x, 3 for x, 4 for x, until something matches. And so the first two I used AI. This isn't the actual test. This is practice. But I used Poe, one of the AIs in Poe. I think Claude Instant, to break down how to do the formulas right. And I thought, oh my, it's those things. Haven't done them in forever. Anyway, I'm going to try the substitution thing and see what happens. So now on the accuplacer, you don't use a whiteboard, I don't think. You use paper and pencil. But CLEP, which I'm going to do, and I'm not going to do math on CLEP. On CLEP, it's a whiteboard and a pencil marker. I don't know how that's supposed to work. It's supposed to stay in the view at all times. I don't know. Seems like a distraction, but whatever. I've never done this before in my life, so I don't know. Apparently people that do this regularly are good at writing backwards, but I can't even write forwards. So this is number 3. And those are my choices. So I'm going to start with the number 1. And I'm going to do 3. So 1 to the power of 2 is 1. So 3 plus 25x. 25 times 1 is 25. How is this going to help me? Oh boy, this isn't going to help at all. Regardless, just keep it going. Yeah, I can see I'm taking the wrong approach here. 28 minus 18 is 10. This is not the right thing to do here. Now I see it. X squared this is other practice for other stuff though, so x2 squared is 4. 3 times 4 is 12, plus 25 times 2 is 50, minus 18 equals, yeah, this is a rabbit trail. 62 minus 18 is 52, minus 8 is 44. This is going no place. Yeah, this is a mistake. So I guess I'm going to have to do it. I did say advanced. Guy with the substitution. So much for substitution. See, there's rules for these. You're supposed to memorize certain things. You see this format, you do the thing. And what is the point of memorizing things that you can look up? Really? Here's a nice calculator. Basic. and the square root. Okay. Neither, which helps me right here. Highlighting does not help me. So at this point, I'm lost. What can I plug in here? I see x minus 9. What does that mean? It's a factor of the polynomial. So there's two factors. Okay. So starting at the right, I mean, 9 is a factor of 18. 3 is not a factor of 18, so it wouldn't be x plus 3. But 2 could be a factor, and so could 1. So number 3 or 2, the second one doesn't seem right. So what about x? Can I just do x 25x and ignore the minus 18 now that I have that it's one of those three? Okay. I don't think I can. Because what's the square root of 25? Is that a square root? No, it's factors of 5 and 5. Oh, it's 5. Yeah. But so what? I mean, if you take the square root of all the x's, you get 5 times the square root of x. And the thing on the left becomes 3x. 3. Is that how it works? Is that how it works? If I take the square root of 25x, right? I get 5 times the square root of x, right? No. That's not right at all. I don't know. I don't do this. I don't want to look it up, though. I'm here at the test with unlimited time, in theory. I can sit there, remote proctor can sit there and just watch me. You're not supposed to talk to yourself, though. That's going to kill me. Because I got to talk to myself. I'm just going to do the square root of... I'm just going to do the x's all by themselves. Can I do that? Can I just take the square root of this part? Can I just do x squared plus 25x? Can I just do that? I really want to do that. I really want to do that. I mean, it would be proportional. But you can't do that. This is absolutely the wrong approach because, great, so you get x plus 5 plus the square root of 5x. You can't do it this way. This is absolutely wrong because this means this is meaningless. You don't know how to do it at all. You cannot reason your way through this. If you don't know how to, if you did not memorize it, but that's silly. A factor of the polynomial. The polynomial is x minus this plus, and then multiplied by y plus this. So something like that. So x minus whatever and x plus whatever. Now all the whatevers. Why are there ants everywhere? Land on the ground for half a second and you get ants? You serious? So this one on the right, can I do two negatives, please? No, because then you can't get a negative over here. So I have several choices here. Okay. I can have a 9, a 3, a 2, a 1. One of these has to be a 9, a 3, a 2, a 1, but they don't both have to be. I only need one factor. Only need one factor. Nice handwriting, Kenny. Oh, beautiful. Need. What is that? So can I substitute my way into this, out of this? It has to equal 18, this part. So both of these will not be there, only one. So you only need to concern yourself with one of them. The thing is, this is so absurd. You have no idea what you're doing. How does it get from this format to that format? Maybe it doesn't, and I've got it wrong. I can't reason my way out of this. I cannot reason my way out of this problem. Purely rote. It is a purely rote question. I mean, I can solve it with substitution, but you know, this is looking for a simplification. I know you need a negative and a positive. And I want to know why. I can get a nice square root of 25 right there. It's 5. Beautiful. 3. It does have something to do with 18. It's 6. So what? I need to know why this works. What is this called? What is the history of it? And I can do this. History of the polynomial. Polynomial. What is the history? Nicely done, Ken. History of the polynomial. Give me a video. I'm going to watch a video. Professor Raymond Flood. Do I want you? Yes, I do. I want Professor Raymond. But I need headset for this one.
Gresham College presents Shaping Modern Mathematics, Polynomials and Their Roots by Professor...
And on the right-hand side of the slide, first, systematic classification of cubic equations, those involving x cubed, similar to Alcoa, governor of the city. Quite reasonable, or rather can be reasonably viewed. And
you're a little bit much. Turn off my mic for now. We're going to watch a video.
Let's explore the notion of a polynomial. So this seems like a very complicated word, but if you break it down, it'll start to make sense, especially when we start to see examples of polynomials. So the first part of this word, let me underline it. We have poly. This comes from Greek for many, and you see poly a lot in the English language, referring to the notion of many of something. So in this case, it's many nomials. And nomial comes from the Latin nomen for name. So you could view this as many names. But in a mathematical context, it's really referring to many terms. And we're going to talk in a little bit about what a term really is. But to get a tangible sense of what are polynomials and what are not polynomials, let me give you some examples. And then we could write some maybe more formal rules for them. So an example of a polynomial could be 10x to the 7th power minus 9x squared plus 15x to the 3rd plus 9. This is a polynomial. Another example of a polynomial, 9a squared minus 5. Even if I just have one number, even if I were to just write the number 6, that can officially be considered a polynomial. If I were to write 7x squared minus 3, let me do it in another variable, 7y squared minus 3y plus pi, that too would be a polynomial. So if these are examples of polynomials, what are examples of things that are not polynomials? Well, if I were to replace the 7th power right over here with the negative 7th power, so if I were to write 10x to the negative 7th power minus 9x squared plus 15x to the 3rd power plus 9, this would not be a polynomial. So I think you might be sensing a rule here for what makes something a polynomial, that you have to have non-negative powers of your variable in each of the terms. And I just use that word term, so let me explain it because it'll help me explain what a polynomial is. A polynomial is something that is made up of a sum of terms. And so, for example, in this first polynomial, the first term is 10x to the 7th. The second term is negative 9x squared. The next term is 15x to the 3rd. And then the last term, maybe you could say the fourth term, is 9. And you can see something, let me underline these. So these are all terms. This is a 4-term polynomial right over here. And you can say, hey, wait, this thing you wrote in red, this also has 4 terms. But we have to put a few more rules for it to officially be a polynomial, especially a polynomial in one variable. Each of those terms are going to be made up of a coefficient. This is the thing that multiplies the variable to some power. So in the first term, the coefficient is 10. And let me write this word down, coefficient. It's another fancy word, but it's just a thing that's multiplied, in this case, times the variable, which is x to the 7th power. So the first coefficient is 10. The next coefficient, and actually let me be careful here, because the second coefficient here is -9. So we are looking at coefficients. The third coefficient here is 15. And you can view this fourth term, or this fourth number, as the coefficient, because this could be rewritten as, instead of just writing it as 9, you could write it as 9x to the 0 power. And then it looks a little bit clearer like a coefficient. So in general, a polynomial is the sum of a finite number of terms, where each term has a coefficient, which I could represent with the letter a, being multiplied by a variable, being raised to a non-negative integer power. So this right over here is a coefficient. It can be, if we're dealing, well, I don't want to get too technical. It could be a positive, negative number. It could be any real number. We have our variable, and then the exponent here has to be non-negative integer. So here, the reason why what I wrote in red is not a polynomial is because here I have an exponent that is a negative integer. Let's give some other examples of things that are not polynomials. So if I were to change the second one to, instead of 9a squared, if I wrote it as 9a to the 1/2 power minus 5, this is not a polynomial because this exponent right over here, it is no longer an integer. It's 1/2. And this is the same thing as 9 times the square root of a minus 5. This also would not be a polynomial. Or if I were to write 9a to the a power minus 5, also not a polynomial because here the exponent is a variable. It's not a non-negative integer. So all of these are examples of polynomials. So there's a few more pieces of terminology that are valuable to know. Polynomial is a general term for one of these expressions that has multiple terms, a finite number, so not an infinite number, and each of the terms has this form. But there's more specific terms for when you have only one term, or two terms, or three terms. So when you have one term, it's called a monomial. So this is a monomial. This is an example of a monomial, which we could write as 6x to the 0. But you could also, another example of a monomial might be 10z to the 15th power. That's also a monomial. Your coefficient could be pi. It could be pi. So we could write pi times b to the 5th power. Any of these would be monomials. So what's a binomial? Well, binomials where you have two terms. Monomial, mono for one term. Binomial is you have two terms. So this right over here is a binomial. Binomial. You have two terms. And all of these are polynomials, but these are subclassifications. So it's binomial, you have 1, 2 terms. Another example of a binomial would be 3y to the 3rd plus 5y. Once again, you have two terms that have this form right over here. Now you'll also hear the term trinomial. Well, trinomial is when you have three terms. Trinomial. And this right over here is an example. This is the first term, this is the second term, and this is the third term. Now, the next word that you will hear often in context with polynomials is the notion of the degree of a polynomial. And you might hear people say, what is the degree of a polynomial? Or what is the degree of a given term of a polynomial? So let's start with the degree of a given term. So let's go to this polynomial over here. We have this first term, 10x to the 7th. The degree is the power that we're raising the variable to. So this is a 7th degree term. The second term is a 2nd degree term. The third term is a 3rd degree term. And you could view this constant term, which is really just 9, you could view that as, sometimes people will say the constant term, sometimes people will say the 0th degree term. What is the, will be the degree polynomial? Degree 5, degree 5. A few more things I will write this down. Well, it usually means, it can mean whatever is the first term is the coefficient, standard form. Standard form, highest degree term. Because but here I wrote x squared next. X to the third term here, or here to the 7 is the noble words to be. In this expression, we're dividing this third degree polynomial by this first. Simplify 3x squared minus 8x plus 7 plus 2x to the third minus x squared plus 8x minus 3. So when they simplify this, we're essentially just going to add up like terms. And just as a reminder, we can only add or subtract like terms or simplify like terms. And just a reminder what I mean by that, if I add an x squared to an x squared, these are like terms. They're both x terms raised to the same power, the same degree. So if I have one x squared and then I have another x squared, well, then I have two x squareds. This is 2x squareds. If I have an x to the third, let's say I have 3x to the thirds plus another 4x to the thirds. Well, that means I have 7x to the thirds. 7x to the thirds. I can't take an x squared and add it to an x to the third. I cannot simplify this in any way. So this you cannot simplify. Cannot simplify. These are not like terms just because they both have x's. The x's are not to the same degree. So with that in mind, let's look at the x's that are the same degree. Let's start with the highest degree. So the highest degree, or the highest exponent on an x, that can't be merged or added to or subtracted to anything else. So let's just write that down. So we have the 2x to the third. We have a, I'm just rearranging it really right now, but I'm putting the, let me write that down. So pi, and then you have a negative 3 over here. You have a negative, rearranged the thing so that the like that we're taking away an x squared. 0. I could write a plus 0 here, but that's 3. Well, that is just clearly 7 minus 3 is 4, so I have plus
In this video, we're going to talk.
If you're a first or second year med student taking anatomy and you're feeling a little bit overwhelmed because of how much information.
In this video, we're going to talk about how to factor polynomials by taking out the GCF, by using difference of perfect squares, sum of all three x's and all two y variables. So there's nothing left over. Y cube. So So what number goes into 8 and 12? 4. 4 goes into 8 and 12. And how many x variables can we remove from both terms? On the left side we have 2 x variables, on the right we have 1, so we can only remove 1 from each term. And the same is true for y. We can remove 1 y from each term. So if we take this term, 8x squared, and divide it by our GCF, 4xy, we're going to get 2x. And if we divide 12xy squared by 4xy, that's going to give us 3y. So that's what's left over. To show your work, you can do this. 12xy squared divided by 4xy. Notice that the x's cancel. 12 divided by 4 is 3. Y. What is the greatest common factor between 30 and 60? And we could take out 2 and divide it by is 3. And we took out all 3 x's and all 2 y variables. So there's nothing left over. Now for the next term, negative 60 divided by 12 is negative 5. And out of this, so how would you factor this expression? X.
Okay. Slowly coming back to me. So in this case, I can't use the greatest common factor for all of them. Can I? So that there is 18x to the 0 power. I think it's either 3x minus 2 or x minus 9. I guess. Would that make it 9? I don't know what I'm answering here. I'm looking at it wrong. Time to turn off my microphone.
Minutes left. Shoot. Last one. Alright, what I'd like to do is show you guys how to factor by grouping. Whenever you see 4 terms, anytime you see 4 terms, automatically think in your brain factor by grouping. And the reason why we call it factor by grouping is what we're going to do is we're going to group our first 2 terms and are going to group the last 2 terms. Okay, so that's really all we're doing because we can't. There's no special factoring technique that we have for 4 terms. So if I can group the first 2 terms and group the last 2 terms, what I'm going to do is I'm going to specialize now in just factoring out those first 2
Okay, my microphone's back. This is so painful. So I looked at one of the AI things, and the very first step, something I never expected. You multiply get the term right. The coefficient. So the coefficient of the quadratic term. Oh my gosh. That 3, this little 3, is the coefficient of the quadratic term. The coefficient of the quadratic term. It's the multiplier, the coefficient, okay. Coefficient of the quadratic term is x squared. So because you can combine, because 3 is really 3x0. It's not 3 you're adding up, it's 3x0 times. So it's 3x0 times x squared plus, oh no, there's no such thing. Well, there is. Plus 25x is x to the first power negative 18x to the 0 power. Is that right? Is that right? Where's that po you were just using? Is 3x to the 0th power the same as 3? And because the coefficients are the same, you can play games with them. So this is a form of grouping. So what you do now is 3x to the 0 times negative 18x to the 0, which equals negative 54x to the 0. If you just kept the x to the 0 on there, it would have saved me a lot of time. This doesn't mean I can answer the rest of the question, but like, I don't know what to do now. move on to the next step of that video. No. With the AI. Look for two numbers that multiply to give 50, negative 54, and add up to 25. Why? Because these are really being added to each other, plus a positive, plus so 25x is really plus 25x to the 0 power times 1x to the first power so look for two numbers that multiply. I love that I'm so slow here. Nope. I almost had it. I don't think I can do this. I could once upon a time. Am I really gonna take algebra? Am I really? Am I really gonna take algebra? I think so. I'm just gonna guess now. Wow. I think I saw the answer. I didn't see the answer, did I? This is so Cheatsville. 3x minus 2x plus 9. 3x minus 2. See, I never would have got it. But I did have it right. 2 times 9 is negative 18. Negative 8. Had that format right. 3x squared. So where's the 25 come from? How do you get 25? I get the 3x to the power of 2 because you multiply. Oh, wait. 3x to the power of 2. Oh. Did the 25 just cancel itself out? Where did it come from? Fucking amazing. I have no idea. I have no idea. I don't want a trick. Well, I do. Oh boy, I should. Oh, this is so amazing. And I'm gonna need this if I do chemistry, which I have to do. I gotta do chemistry. I need to know this. I need to know this. Wow. The kids. The greatest common factor. That's what that was. I think that's what I'm going to try. rabbit trail am I going down? Buy my ugly sandwich. I can do this type of thing right now. I won't be able to do during testing. But I really want to understand it. So greatest common factor. 10 minutes, microphone off. Oh, I was talking to myself. Okay.
In this video, we're going
Are your kids in grades 6 to 11? Harvard has made SAT and ACT score submission optional in its admissions process. If they don't require SAT and ACT scores, how will Harvard and other Ivy League universities choose from 100,000 plus college applicants? You see, the secret to increasing your child's chances of getting into a top university isn't.
In this video, we're going to talk about how to factor out the greatest common factor, or the GCF. So let's start with the first example. We have a binomial, which consists of two terms, 12x and negative 20. How can we take out the greatest common factor? So what is the highest number that goes into 12 and 20? 12 and 20, they're multiples of 2 and 4. But 4 is greater than 2, so 4 is going to be the greatest common factor of 12 and 20. 12x divided by 4 is 3x. Negative 20 divided by 4 is negative 5. So this is our answer. The GCF that we factored out was 4. Now, let's try the next example. So what is the greatest common factor that we can take out? 6 and 18, they're both multiples of 6. So we can take out a 6. Now, both of these terms contain at least one x variable. So we can take out an x. Each of these terms are divisible by 6x. (6x squared divided by 6x is x. 18x divided by 6x is positive 3. So this is the answer. It's 6x times x plus 3. Now what is the GCF for the next one? 14 and 35 are multiples of what number? 7 can go into 14 and 35. Here we have an x squared, here's an x, so we can take out at least one x out of the 2. So the GCF is 7x. 14x squared divided by 7x, that's going to be 2x. Negative 35x divided by 7x, that's going to be negative 5. So that's the answer. Let's try another.
Only the second time I've looked at con, or third time. Wow, they really are good. I can't believe I'm like I almost understand what's happening there. Once I do, it'll be easy. Everything's easy once you know how, but until you know how, it's not. It's like it's right over the other side of a wall. Almost there. Get a water. Come back. Microphone? Yeah, you're on. Gonna watch a video on the greatest. I almost understand this.
Another similar example. So let's say we have 36 x to the 5 minus 63 x cubed. What's the GCF in this case? The highest multiple, 36 and 63. What is the highest number that goes into both? Both of those numbers are divisible by 3, and they're divisible by 9. So 9 is going to be part of the GCF. Now looking at these two, the smaller of them is x cubed. So x cubed is going to be part of the greatest common factor. Now if we take 36x to the 5th power and divide it by our GCF, this is going to be 36 divided by 9 is 4. X to the 5 divided by x cubed, we need to subtract the exponents. So we're going to get 4x squared. That's going to go in here. Next, we need to divide this by the GCF to get the next term inside the parentheses. So if we take negative 63x cubed and divide it by the GCF, these two will cancel. Negative 63 divided by 9 is negative 7. So we're going to have a minus 7 inside here. So that's how we can factor out the greatest common factor in these problems. Now let's move on to the next example. Try these two problems. Let's say we have 2x squared minus 8x plus 10 and also 27x to the 5th power plus 36x cubed minus 45x squared. So go ahead and factor these expressions by pulling out the GCF. So here we have a trinomial with 3 terms. What we can do is take out a 2. All of the coefficients are divisible by 2. So that's going to be the GCF, the greatest common factor.
A house or a laptop? Which one do you think is worth more? Well, definitely not the house, because it not only costs millions to buy, but you also have to pay thousands to maintain it every month.
Factor.
Now, CLEP, which I'm not doing here, CLEP needs to have the whiteboard visible at all times. I don't know how that's supposed to work. But I imagine it's very similar with the paper. I'm using the whiteboard because it's more difficult, and so that was an eye-opener, though, that x 18 is the same as 18 x to the 0 power. That was huge, and that 3 was really 3x to the 0 power. So erase that, hope I don't forget. Because now I'm moving towards a new goal, and hopefully I don't forget this one. Just erasing. holding on to that note. So now I'm going to take the route of doing the... Is this correct or upside down? That is... I can't tell. Are you backwards or forwards? Yeah, you're fine. God forbid anybody's watching this now. 1 hour and 30 minutes of your life wasted if you were. So I just learned about the greatest common factor. See, I'm looking at this. And I don't see a greatest common factor to both of them. So that method doesn't help. Okay. So back to the video. Microphone.
Two x squared divided by 2 is x squared. Negative 8x is 5 terms. The 5 is that way. Divisible 7 divided by 2, x squared. Negative 45 divided by 9, 1. X, the greatest common factor. So when we pull it out, we only need to divide it by outside here, minus 2 here. We're going to have 2, 2. Clearly, and the answer is going to be 3x minus 3. 3x. What is the GCF in this example? Factor and then by 5 plus 1.
Here's one thing you need to do before buying anything online. Don't spend another dime on Amazon until
In this video, we're going to talk about how to factor polynomials. So let's start with some simple examples. How would you factor this expression? On the bottom, we need to take out the GCF. We could take out all of the coefficients are even. So we're going to 4 divided by 3 is 8. And we're going to have x plus 8, we can divide to get rid of the 2 in the front. For the last one, this is a problem that looks like this. 2x squared minus 5x minus 3. What would you do to factor it? Now notice that there's no GCF that we could take out. 2, 5, and 3, there's no common number that we can divide to get rid of the 2 in the front. So in this situation, what we need to do is multiply the leading coefficient by the constant term. 2 times negative 3 is negative 6. Next, find two numbers that multiply to negative 6 but add to the middle coefficient of negative 5. This is going to be negative 6 and plus 1. Negative 6 times 1 is... What we need to do is multiply the leading coefficient by the constant term. 2 times negative 3 is negative 6. Next, find two numbers that multiply to negative 6 but add to the middle coefficient of negative 5. This is going to be negative 6 and plus 1. Negative 6 times 1 is still negative 6, but adds up to negative 5. Now, what we're going to do now is we're going to replace the middle coefficient with negative 6x plus 1x. Keep in mind the value of the expression is still the same because these two still add up to negative 5x. Now our next step is something called factoring by grouping. In the first two terms, we want to take out the GCF, which is 2x. 2x squared divided by 2x is x. Negative 6x divided by 2x is minus 3. Now in the last two terms, take out the GCF. There appears to be none, which in this case, we're going to take out a 1. So when these two things are the same, you're on the right track. So now, we're going to factor out x minus 3. If we take out x minus 3 from this term, we're left with 2x. If we take out x minus 3 from that term, we're left with plus 1. And so the 2x that you see here goes here, and the positive 1 goes there. And so this is the final answer. If you want to check the work, you can FOIL this expression, but it's going to give you what you started with in the beginning. Now let's try a similar example for the sake of practice. If we take out x minus 3 from that term, we're left with plus 1. If we take out x minus 3 from this term, we're left with 2x. If we take out x minus 3 from that term, we're left with plus 1. And so the 2x that you see here goes here. The work, in fact, 6 times negative 15 is negative 90. Now we need to find two numbers that multiply to negative 90 but add to positive 1. So this is going to be 9 and 10. We're going to use negative 9 and positive 10. Negative 9 plus 10 is 1. Now our next step is to replace positive 1x with negative 9x and positive 10x, and then factor by grouping. In the first two terms, we can take out a 3x. 6x squared divided by 3x is 2x. Negative 9x divided by 3x is minus 3. In the last two terms, we could take out a 5. 10x divided by 5 is 2x. Negative 15 divided by 5 is negative 3. So now we're going to factor out 2x minus 3. So in the next step, you could just write it once. And then what you see here is going to go inside of the next parentheses. So that's going to be 3x plus 5. And so that's how you can factor a trinomial where the leading coefficient is not 1 and when you can't take out the GCF.
In this video, I'm going to show you guys on how to factor a 5-term polynomial, and I'm going to work out these 2 examples right here for you guys. You can see they look very similar, right? So I have 2 remarks I want to make before we do these 2 questions. First, not all the 5-term polynomials are factorable. We can only do the ones that are well decided. And second remark is that they will be hard. Anyways, let's focus on this one first. As you can see, we have 5 terms. As a good habit, we should check to see if we can factor any GCF from all these terms. But no, because first of all, the last one is just a 1, and then for the numbers, there's no other number besides 1, right? So no GCF. And right here, whenever we're trying to factor things out that has more than 3 terms, and that means if we have 4, 5, 6, or even more, we should do this by grouping. This right here, we have 5 terms, and we have a few ways to group them, right? Maybe you can group the first 2 together, and then the second 3 like this, or the first 3 like this, and then the last 2 like that. And we just have to try it, and I just mentioned it, it's going to be hard, right? Let's look at this, and let's think about this carefully. I'm going to group the first 3 terms like this. Well, why? Because first of all, I can factor out x squared, right? That's good, and without being done, let's group the last 2 like this then, and let's see what we get. For these 3 terms, we can factor out x to the 2nd power, and then for the leftover, well, for the first term, originally it was x to the 4, but we took the 2 out, right? So we have x squared, and then we add the 2. We have x to the 3rd, but we factor out 2 of them, so x to the 1st. The x squared was out, so plus 1, just like this, right? So that's a progress. And then let me write down plus x plus 1. What can we factor out? Nothing too much, right? So let me just factor out a 1, and then let me put a parentheses around this, x plus 1, like that. Well, this entire parentheses in black and this entire parentheses in black, they are not the same, so we cannot factor things out yet, right? However, as I told you guys earlier, these questions are well decided. Look at this right here, x squared plus 2x plus 1. What can we do with it? Well, we can factor this, and this is going to
Okay, I'm falling asleep here. I guess my brain has learned all it's going to learn about that particular area for today. I mean, I'm certainly going to have to go back to it again, but that's more than I expected. That's more than I expected.